Hello guys, good afternoon. Welcome back. We will start with our Docker session. So today is Docker Day 9 session, and today the date is 28th of your December 2025, and the timing is afternoon to 4 p.m. IST. So guys, so let us continue our discussion on Docker Day 9 session. So in the last session, that is on Day 8 session, we had covered some of the Docker instructions, right? Basically, we started with writing the Docker file, and also we try to understand about how we will be able to write. So whatever we all these days we were doing it everything manually, right? By taking any plain OS virtual machine and then installing all the package and making some kind of an application to run. So now our requirement is that actually how we can do the same step what you do in the virtual machine. The same thing I should be able to do it in my Docker actually. It means that I need to create when I'm creating a container, I need to have my application running as part of my container, right? So that's what it means that you want to containerize it actually. So for that we usually write a Docker file. And whenever you want to write a Docker file, we need to understand about the Docker instructions. What are the Docker instructions are provided? So basically, you have to go to the Docker reference page, and from there you will get all the Docker instructions which are used for writing a Docker file. So that's what we had pretty much covered in our last session. Now, what we're going to do today, guys, today also what we'll do, we will try to go a little bit one more deep level in understanding all the Docker instructions, whatever we have. I think in the last session, I had just I had just wrote one Docker file where we we are supposed to run our application Spring Pet Clinic actually, right? So this is what we are supposed to write it. So we had written it. So just we wrote it, but we didn't execute it, right? So in today's session, we'll also see this also, like how to write a Docker file for running our Spring Pet Clinic application, right? Before that, let us try to get into a little bit deep about all the instructions, whatever the Docker instructions are there, right? Let us try to get into understanding about each and every Docker instruction, and let us also try to write some few Docker files so that we will get an idea about like how you can use these instructions for writing a better Docker file. So today we might not write a very good Docker file because we are in a learning phase. So we might write a very kind of a bad Docker file, which kind of a work it works actually. No doubt it will work. But if you ask like what if that is a better Docker file which we are writing, I would say it's a very bad Docker kind of a file which you are writing. So today we might be writing a very bad file or a bad way of writing a Docker file. But tomorrow, over a period of time, you could see that we will be writing in a better way actually because you need to, like when you write a Docker file, you need to make sure there are many best practices are there. As I said, right, we need to follow those best practices for writing a Docker file. So today we might not, but eventually in couple of days we will see that we will be able to understand or write a better Docker file, right? So the first day you might write a very rudimentary kind of a Docker file, but after 3 4 days you will see that there will be some kind of a changes in writing the way we write Docker file. Okay, so now, so what would be today's agenda, guys? Today agenda is mostly on our Docker file itself, actually, right? So let us try to go into the Day 9 session and just say that we will continue with the Docker file. Okay, so we know that Docker file has instructions to build a Docker image, right? The first instruction what we use is always from instruction, right? So basically from instruction is one of the very important Docker instruction what we use. Basically from is something where it helps in selecting the image actually. It means that whenever you want to start writing a Docker file, we need to use some kind of a base image, we say. So that base image we will be trying to use with the help of a from instruction, right? So the base instruction can be the base image which you are choosing. It depends upon your requirement. Suppose in case if you are trying to run any kind of a Java based application, you might use a base image as something like OpenJDK, or else you can even use a Ubuntu OS as your base image, where you will be installing the Java, and you will be deploying your Java application in that Ubuntu base image. Similarly, there are many other base images are there where we can use those base images. So today, let us try to explore one or two base images, very base images, which we will use in our day-to-day activity whenever we write a Docker file. So again, as I said, right, the base image is something which, based on our requirement, we choose a certain base image, right? So today we are just discussing the how to build a Java application. So we will try to choose certain base image. Tomorrow you might be developing a Node.js application, you might be developing a Python based application, you might be developing a React.js based application. So you might be building many different kinds of application. Based on the application, we tend to choose certain base images. Okay, so what are all those base images? Yes, eventually we will be learning all those base images in our upcoming session. Okay, so today what we're going to do, we're going to then say that. So this will, this helps in selecting the base image actually. So guys, what we'll do today, we will try to do some kind of an experiment today and try to understand that how this instructions works, file instructions works, and what are all the things we can pass by using this Docker instruction. Like for example, if you're using firm, are there any kind of parameters where you can pass it or not, right? So all such things we will be able to understand in today's session, as well as in all our upcoming session, we will be using all those options along with this instructions actually. Right. So what I would say that I will try to do some kind of an experiments actually. Okay. So in that experiments, what we'll do basically, for a from instruction, what you can do that, like let me start exploring the options of from instructions. Let's see what are the options we have. And the second thing is that let us try to choose different base images. Right. So let us try to experiment this and see how exactly your from instruction works actually. Right. So, okay, for that, what I will do, I will go to my desktop, I'll go to my batch 2, and I'll go to the Docker. You could see that you have something like a Docker file images. This is a folder you created, right? So let me know one thing. Let me open the Visual Studio Code. So I just said code dot enter. Okay. So I think in the last session we had written a very small kind of a Docker file, right? So this is what the Docker file we had written, right? But eventually we will be writing a better Docker file. Okay. So let us do one thing. Let me create a new folder. Okay. What is that folder? I'll just say experiments folder actually. Okay. I think it is outside. Let me drag it outside. So I have a experiment folder. Expri, right? What is it? Rename ex. Okay, guys. So in the experiment, what I will do basically, I will tend to write many Docker files, guys. So let me do one thing. Let me try to create some file, like something like Docker file one. I will write actually, right? Or else I'll just say I have to create a directory, right? So sorry, I'll try to create a directory. So here inside it, I will try to create one more directory, something like Docker file one directory. Like I will write it. So here what happened that I will try to write your main Docker file, right? Am I clear, sir? Is it fine? Okay. Now, if you go to your documentation and if you try to search for Docker file reference, and if you go to this link, so this link, as I said, right, it has all the Docker instruction, guys, Docker file instruction. You know to refer to this always. So you need to refer to this documentation always. So this has all the instructions, but if you see it, you have something as a from instruction. So it creates a new build stage from a base image. That's what it means, that whenever you are trying to write a Docker file, you have to choose certain base image, and you will be able to use that base image with the help of a from instruction. So if you click on this, it will take you to the kind of a reference page where you will get to know some information about what is this from instruction is all about, right? So now if you see it, you have from, and then you could see that here it is showing as a platform. So basically, if you ask me, like you are having two platforms basically. Broadly speaking, you're having two platforms. One is a AMD 64 and other is a ARM platform actually. ARM platform. So guys, whatever the servers you have, generally in our whenever we have the servers, either if we take any kind of a virtual machines from the cloud, or else if you try to go to your data center in your company where they are having a lot of servers, you will see that mostly the servers are AMD 64 processor servers, or else IA64 servers actually. These are the kind of servers and the processor types which are used actually. Now, whenever we write any kind of a Docker file, we need to make sure that we need to choose certain platform. It means that basically our Docker file works or runs under certain processor architecture, because we all of us are deploying all our application in basically either in the cloud platform or either in on premises. In both, either in the either in the cloud or either in the on premises, wherever you generally will see that you will always see the AMD 64 as a processor actually. So AMD is nothing but your AMD company processor, and 64 is number 64-bit architecture actually, right? In today's time, right, all our laptops, even including laptops or any kind of a servers you go, all are 64-bit, 32-bit processor or 30-bit architecture. Almost it is obsolete. Nobody uses the 30-bit architecture, right? When it comes to servers also, you will not see any kind of a 30-bit servers actually in the real time. All are 64. So it means that when I want to write any kind of a Docker file for my requirement, then in that case, what happened, right? You have to choose certain platform. So since most of the platforms are AMD 64 platform, guys, so there is no need to worry. You can ignore this option of using it. Okay, like hyphen FN platform like this. Okay, you need not to really mention, because most of us are all building the application for our AMD processor itself actually. So hence what happened, right? You can ignore it. What of the ARM platform? ARM, basically ARM processor are very can say that they are very low consumer power. It means that whenever you want to develop or you have some kind of an ARM processor where you want to develop the Docker file, then you, if it is an ARM processor, then you have to mention hyphen FN platform is equal to ARM actually, ARM. So ARM processor are very small, lightweight processor we say, and it always consumes very less power, right? And ARM processor, basically it is meant for you to write some small specific application. Say for example, you have an ARM processor, or you are having something like ARM board. So basically ARM board, basically ARM board or ARM processor board, usually what happen, guys, you will be running some specific application. Say for example, you are running some kind of an IoT based application, right? IoT based application or some specific application you would be running. So in that case, what happened, right? You will many of us will tend to go with the ARM processor. So ARM processor, it's nothing but it's a small board what we get actually. So there what happened, right? You can run a very specific application. So even in ARM board also, what we can do, that we can even run our Docker actually. Docker container we can run even inside the ARM processor, because ARM processor also supports a Docker containerization. You can go and install the Docker daemon, or as the Docker package, you can go and install it, and also you can run any kind of application which you have built through a Docker file. You can run it actually. So in that case, guys, when you know that actually, okay, I'm developing an application and I need to write a Docker file where my applications runs under the Docker file, but the Docker container will be created in the ARM processor, ARM processor. Then in that case, what happens when you are developing the Docker file, whenever the DevOps engineer is developing a Docker file, you have to make sure that he is using this hyphen FN platform is equal to ARM. Like that, he has to use it, right? Now that is one thing, and the second question what comes to our mind, that when we are developing the Docker file, right, for container, for getting a containerization application, what would be kind of an operating system basically we use it actually? Is it Linux or is it Windows? Right? Yeah. Basically, what happened, right? You categorize into two things only, guys. One is a Linux and other is a Windows operating system. Because since Windows also supports a Dockerization Docker technology, because a lot of changes has been done by the Microsoft company to make sure that the Docker container works even in the Docker OS also. So hence what happened in today's time, even you will see that many of the .NET based applications are developed right by the developers. And when you want to make or when you want to containerize those .NET based application, obviously what happens, you need to write a Docker file. So when we are writing a Docker file, you need to make sure okay on which platform you are writing, either it's a Windows or Linux, right? So it based on the image what you choose it actually. If you might choose either the Linux based image you will choose, or else you can even choose the Windows based actually. Windows based also you can choose it. So obviously, when you're choosing the Windows-based, basically it will be kind of a 64-bit Windows operating system you will choose as a base image, and on that base image, what you do that you go and try to deploy your .NET-based application. Right, so these are the two flavors of operating system you will generally get it, but most of us you know that like we when we are working on organization, yes, we work most of the our applications are running on the Linux platform only. So when we write a Docker file, we tend to use the base image where it would be kind of a Linux based image actually, right? But whereas in some companies where they are strictly working on only on Windows platform, they are developing all their application through .NET framework only, then you have to use the Windows based base image you have to use. That also we will see, guys, how to use a Windows based base images, how to use it also we will try to see in our upcoming session. Am I clear, sir? Now here, if you come here in the from instruction, they're clearly saying that this is what the platform. Right now, I'm ignoring it. Okay, I'm not specifying like hyphen platform is equal to ARM like that. I'm not specifying. Right now, I'm ignoring because most of our work, whatever we are doing today, is on AMD 64 platform only. That's what. And even my machine, our machines all are AMD or x86 platform. Intel's x86 platform or IS64 or AMD 64. So that's what we need not to really worry much about this platform option. Then we use some image name. Now here what happened, based on your requirement, use your image name. Like for example, as I said, right, when you are trying to develop any kind of a Java based application, you know that there are many images are there which supports for a Java. Like for example, OpenJDK Java, Eclipse is there, Eclipse Terminus is there. Like that, many images are there. You can use any of these images actually, right? For example, you can even use Ubuntu image, you can even use Alpine image, right? So you can choose any kind of an image. Some images might have the Java built in it. It means that Java is already comes as a pre-installed, and in some base image you will not get any kind of a Java. Something like you to choose either Ubuntu or Alpine, right? These are the OS images. Actually, it doesn't have any kind of a Java. Later we have to build or install the Java on that actually, right? So that's what this is image. So our main priority is to understand that what kind of a different images we will choose it for our requirement. That is what our agenda for today's session, right? It's not only with the form, with any kind of a Docker instruction, we have to understand what are all the different options are there for those Docker instructions, and like which is the best thing to be used when we are writing a Docker file. That is what we will be learning in today's session. We might not cover all the Docker reference command, guys, because it's a too lengthy. Slowly, one by one, you could see the left side, the table of command, right? You will see that there are so many command, sorry, not command, so many Docker instructions are there, which we need to cover each and everything. So it will take time. It will take 2 3 sessions to complete all these things, right? Okay. Now, suppose for example, you say that Rajesh, I'm developing a Java application. Yes, I will choose one thing. I'll do one thing. I'll go and I'll choose because it's a Java based application, okay, which which I've developed it. I want to make it as a containerized. Then I have to use some base image which supports for Java, or which has a inbuilt Java installed. So in that case, what happened, right? I will use a image by name OpenJDK. Suppose if I'm developing an application on the OpenJDK 17 platform, I need to have OpenJDK 17 version. You need to have it. So then how are you going to find it out? So what you do, we basically go with the Docker Hub. So we'll go to our hub.docker.com, which is nothing but your public repository for all the images. And here what we do basically guys, here I will go and I'll choose something like OpenJDK and say enter. So you could see that this is the official Docker image which it provides. So if you click on it, OpenJDK, you can use this OpenJDK for your requirement. Okay. Or else here you could see that actually there is something like a deprecation notice is there. What is saying that this image which are below, right? It is officially deprecated and all the users are recommended to find a suitable replacement as soon as possible. Some examples for other official images are alternatives. So these are the alternatives what we have. Apart from OpenJDK, you can use either Eclipse Terminus, you can use IBM's Serimo runtime or anything you can use. Suppose for example, if you say that I don't want to use this OpenJDK, I want to use some other image. So you can even use Eclipse-Terminus. Okay, let me click on the Eclipse-Terminus. If you click on it, guys, it will take you to the Eclipse-Terminus. Timirin, this is the image it takes. Okay, since they are saying that it's been deprecated, we want to soon deprecate, but yes, this image is available. Even you can use this image also. So to understand in a better way these images, right? If you come down, they would have given like what are the different architecture where this supports. Actually it supports on your ARM 62, AMD 64, ARM 32, ARM 64, like PPC, RISC processor, like the Windows AMD, like where is different architecture, you this image gets supports. And if you come down, they would have given that what is this exif terminus is all about. They would have given the information about that. Basically, this image will provide the Java runtime environment image. So basically, it provides your JRE environment for you to run the Java application, right? And if you still further come down, they would have given an example of how to use in your Docker file. So they would have given the instruction here. Can you see from Eclipse-terminus colon 25 run and other instructions they have used. This is basically they are using this image, right? And what finally they're doing, they're trying to run your jar file with the help of this image actually. And they would have given the instruction about how to build it and how to run it, everything. So all kind of information you will get it, guys, if you go through that image information. So this is the image, Eclipse-Timirin image. This is the image actually which you can use it. So shall we use this image instead of using OpenJDK? Yes, we can even use this also. Am I clear, sir? So let's see what this image is all about. Say, for example, if you say that, okay, Rajesh, this image, does it have any kind of a Java 17 version? Because I need a JDK 17, right? Because I use OpenJDK. Does Eclipse Terminus also has a JDK 17? Yeah, you can search. Where you'll search, you'll go to the tags. If you go to the tags, and here you could see that you have so many images are there, but I want to filter with the what is that 17-JDK. Let's see whether I will get any image with the 17-JDK. Enter. See guys, you get so many images with this tag 17-JDK, but I want only 17-JDK. Let's see, come down. 17. Can you see here? Just 17-JDK. Yeah, this is what I need it actually. So if you click on it, see, can you see that how to use it? Eclipse-terminus colon 17-JDK. This is how you have to use it. It means that when you are using a form instruction, you have to use this as a base image actually. Am I clear, sir? So shall we write it? Yes. Go here, and what I will do here, I'll just under this Docker file one, I have one Docker file. I'll do one thing. I'll just say from. I will let me copy it and paste it. See, I'm using this image itself actually because this image it has a Java also. Okay, guys. Right. So now what I'm doing here as part of this, I'm just choosing some different image and just trying to understand how this images works actually, whether we can use this image or not. If you use the image, what kind of a benefit you are going to get if you use some kind of a different images. That is what we are going to understand now. Okay. So now what I will do that, guys. So I will be So we will be, I have written already, I have even already created an experiment folder. Inside that experiment folder, what I will do that, I have created one folder where I'm writing Dockerfile. So what I'll be doing that, let's just add from statement in Dockerfile. So this is the only one statement I have written. That's all. No other thing. Now let's see how it works actually. Right? So for that, what I will do that, let me do one thing. Let me log into my Docker server where Docker I have installed. So let me copy the public IP. Go here and try to go to the download where you have the putty. Just log into that. Ubuntu at the rate. Give the public IP. Okay. So I have logged in, guys. So just to verify if it's a Docker info, yes, everything is fine. Now, if I go to the Docker images, so here what I will do that I will try to create one directory by name experiments here, cd to experiments, right? And I will just say mkdir again. I'll just say Docker file one. This is the first example. Go to the Docker file one folder ls, and here I'll try to create one file as a Docker file. So here you could see that I'm using the case sensitivity. This should be uppercase. So here I have to write a Docker file. You have to use this convention. So the uppercase should be D and all other characters should be small. So is it mandatory? As I said, right? It's not really mandatory. You can write your own name. But as of now, today we are strictly following the convention only. Tomorrow you will see that I'll be writing my own Docker file name. Apart from this name, I'll give some other name. Then also you can build and you can run your container. It's not really mandatory, but still some people use this standard a lot in the organization. Still today also you'll see this file name exist in most of the folders where they want to build a Docker image, right? They use this convention of writing a Docker file. So we'll try to follow the same thing for a few days actually. Open it. So now what I'll do, Rajesh, I'll just copy this instruction. That's all. I'm not doing any big thing here. I'm just using this from instruction, and this is the only one line I have this in the Docker file. Am I clear, sir? Now the thing is that, guys, actually that, so you have this file. Okay. So Rajesh, shall I try to do a Docker pull and check it out whether this image I'll be able to download it or not? Yeah, let's see. So if I try to do a Docker pull, and if I just try to copy this whole Eclipse image with the hyphen colon JDK, let's see whether you're able to pull it or not. Right? Yes, you're able to pull it. So it's download completed. If I try to do a Docker image ls, you could see that actually, guys, you have this image. Am I clear, sir? And you are having this is the image ID. Okay, this is the image ID. And this is what the disk space, what it is consumed by your Eclipse image actually. Okay, for this for let us try to remove this actually. Docker image RMI, and then specify that image name J colon 1.0. Let's remove this. Okay, and try to do a Docker image ls. Oh, it's still there. Okay, so I'll just let me check Docker container ls whether any. Okay, it's running actually. So I think I didn't remove it. Docker container stop, or just say rm hyphen f and give the container ID. So you have killed the container. When I try to do a Docker container ls, so nothing is there. So now you can remove that image actually. Docker image RMI J colon 1.0. So you remove the image also. When I try to do a Docker image ls, you could see that only one image is there, which is nothing but we just not downloaded it. So I just download, guys, and you could see that it is having a space of disk usage of 637 MB. Fine, and this is nothing but your image ID. This is nothing but your image ID, right? So now what I will do basically, like I will try to now build a Docker image actually, right? So whatever you're having a Docker file, this Docker file, I'm going to create an image out of it actually. Am I clear, sir? Okay. So what we did now, basically, initially, for us to understand, let's just add from say statement. Okay, that we already written. Okay, what is the statement you have written, guys? This is what the statement, just one line you have written, that's all. Okay, after that, what you did, right? Later, what happened, right? We manually pull the image using Docker image pull and then specify this, right? Or you can just say Docker pull, whatever, right? We execute this and and what is it? Verify the image with the help of a Docker image ls. So we saw that actually that this image is there actually. I mean, when I try to do a Docker image ls, you could see that this image has been pulled now, right? So now what I will do, guys, now let's try to build an image actually. Now let's try to build the Docker. Let's try to build the Docker. Let's try to build the image. Okay. For that, what you do basically, you will try to draw a Docker image. The command is Docker image build hyphen T. Okay. Because guys, I'm using all the experiments actually. So let me give something like a experiment colon V1 version 1. I'll give, right? And let's see whether it works or not. Space and dot. So it means that basically why you're doing dot, because you want to tell to your Docker that your Docker file is there in a present directory. That's what when I try to do a Docker image build hyphen T, you need to give some image name. So I'm giving image name something like experiment colon version 1. That's the first version. Space and you have to give dot. If you're not giving dot, right, what happened at Docker image, it doesn't answer where to search for the Docker file. So when I try to run this, you could see that actually like it is failing it. So hence what happened, you have to tell that, okay, the Docker file is there in the present directory. Like that, you have to mention as a dot actually and say enter. Okay, I think I gave one extra space, right? Space one dot. What happened, guys? Docker image build. I think I did a wrong spelling. Docker image BOID build hyphen T and then say. Now you could see that, guys, you are building an image, your image build has successfully completed, right? When you try to do a Docker image ls, you could see that, guys, you got a new image with the name experiment colon v1, right? And you could see that actually, right? You build the image, so right? So you got these two images basically. Okay, fine, guys. Good. Now, actually, it is to show here something like a created time, but now it is not showing. Earlier, it is to show something like a created time. I think now it is not showing it actually. Okay, fine. So now what you say that, okay, fine, now I have built it. Now, is this is sufficient for us or should I write something else? Yes, sir, we can use some other instructions also. Say, for example, you want to add some kind of a metadata. It means that you want to provide some kind of information for a Docker file. Then in that case, what happened, guys? You have something known as a label. So I'll just say label. So label is one more Docker instruction where you can pass any kind of a metadata. So for example, you have something like an author, okay, is equal to something. I'll just say Rajesh. Okay, this is a label. And one more label I'll add. Label. What is the version of this which you are building? It is a 1.0 version, something like that. So you can add as many number of labels what you want, right? So this is something like we call it as a labels actually. So it means that whenever you want to pass any kind of a meta information in your Docker file, then we will be adding this labels actually. So you can add n number of labels. based on requirement. It is not mandatory that you have to use either one or two only. You can add any n number of, right, like for example, build date, actually something, or date. So today's date you can mention like this, so that you will get to know about the 28th of your, like this you can even mention. So you can add as many as labels you want, guys. Am I clear? Now, but what happened, right? We are adding it. Still, this method is still used in the organization because whenever you are adding it. But now what has happened, right? Because we all are following the OCA format actually, right? Open Content Initiative. So you need to follow writing a label also or mentioning the metadata based on the OCA format only. But this format, it has been followed from very long time. Even today also, a lot of companies, they follow the same way only by using a label, give the some kind of a key and the value. It is like a key and a value, key and a value. But do you have any other OCA format? Yes, sir. We have OCA format also. How the OCA format look like? See, guys, I will tell you how exactly OCA format look like. One second. Where is it? Yeah, here like this it follows actually. This is something like a custom label. What we say. Okay. This is something like OCA label format actually. So in today's time, when you see any Docker file, you will see like this actually. Label like this. For example, when you want to mention about the author name, the label will be something like what is it? Org dot open containers dot image dot author is equal to Rajesh. Like this it will be. Label, what is it? Org dot open container dot image dot, what is it? Version. Something is equal to, what is it? 1.0 version. So this is how they use it actually in today's time actually. Am I clear, sir? This is how they use it actually, the labels. So labels are nothing but it is a metadata information. It means that whenever you want to provide any kind of a data to your Docker file, we use this label actually. So this is how the OCA format it is used in today's time. But okay, but still what happened, this is our older method, but still today also people are using it, and it's not like there's nothing like a harm in using this. It works actually. When you're trying to build it, it takes this label into consideration. But if you see some kind of a latest Dockerfile which in the industry which they are writing, right, they are using this OCA label method. They are using it actually. This is how they are using it actually. Am I clear, sir? Is it fine, guys?
Yes, Rajesh. Yeah.
Yes, sir.
Very good. Good. One second. Sorry, guys, I'm getting a call. One second. Ah, sorry, yes. I'm getting continuous call. Okay, so this is how we write it. Okay, now, guys, let's try to build this because now the first which we build was the version one. Now I added this label, right? Let's see whether it builds or not. Okay, so now what I will do that I will try to copy this whole thing, come over here, and I'll try to open the Docker file here and insert it, and let me copy this. One second, guys. ಸರ್ ಕಳಿಸ್ತಾ ಇದೀವಿ ಸರ್ ಬರ್ತಾ ಇದೆ Okay, sir. Okay. Sorry, guys. I think there was. Okay. Now what I'll do that, guys. Now let's add the metadata using a label instruction, right? So now what I will do that, I will go ahead here and I've added it. Let me save this file and I'll just say Docker image build hyphen t hyphen t and I'll use the name as a experiment version v2. I'll give space dot. Earlier it was v1, right? Now I'll give v2 and say enter. So now you could see that actually, guys, it has built it, right? It has built it. And here what happened, right? It was fast actually, right? And when I try to do a Docker image ls, you could see that, guys, you got one more image which is numbered experiment v2, right? But you could see that the IDs are getting changed here actually, right? Because as and when you keep adding the changes, right, these IDs will keep getting changed. But you could see that the sizes of this, suppose that the experiment V1, right, this image, the size was 634 MB. Even for experiment V2, the size was 634 MB only. So it has not much changed actually, right? The size remains same because here what I'm doing that I'm just adding a label. So adding a label, it is not really making much changes to your size of the image. Actually, the same size is used actually. Am I clear, sir? Till here, are you okay?
Yes,
Okay.
Rajesh. Yeah.
So now it means that actually that using this some kind of Eclipse terminus image, I'm trying to like I'm trying to use this as a base image actually, right? So this base image has certain things actually which we don't know what is it has. Yes, as the name says, 17 if it means that it has the Java installed everything with this image actually. Instead of I using OpenJDK 17, I'm using the Eclipse-terminus image. Yes, obviously this has the Java installed on it, and we can able to run our Java application which has been built on the version 17. Definitely, our application will work. Suppose assume that actually that I want to use some kind of image, Rajesh, which is an empty image actually. It means that it doesn't have anything. It doesn't have anything. So there is an image with the name with the name known as Scratch actually. Scratch. So I can use that also. Like for example here, let me do one thing. Under the experiment, I think I have to create one more folder actually. So the namesake Docker 2, Docker file 2, and I will try to create some file by name Dockerfile here, right? So this is a Docker file. So there is a base image called as what is it? Scratch, which is empty. It means that it doesn't have anything. It's an empty image. Like in Linux, how we have a empty file, right? For example, if I try to create a touch Alice, you will create an empty file actually. Empty file means it doesn't have anything. Similarly, if I try to create mkdir test, test is an empty folder. Test is an empty folder, right? So similarly like that, can I have an image which is like an empty image? It doesn't have anything. It doesn't, even though we call it image, base image, but it actually doesn't have anything. It'll be a zero size actually. So the example is Scratch actually. The example is Scratch. So Rajesh, can I do it? Yeah, I can do it, man. Go here, come here, and then like here what happened that I will just use something like a from what is it? Scratch from scratch. So save this file, and what I will do, I'll go to this server. Here, I think I have to come out from here. I have to create one more directory, the scratch directory, or I'll just say Docker 2 file 2 directory. Inside, go to the inside Docker file 2 directory, and here I'll try to create one file Docker file, and I will try to copy this line. That's all. And let's see whether what would be the size actually. This is just for our experiment purpose, guys. Nothing. This one, if I try to do a Docker build hyphen t, Docker build hyphen t or Docker image build hyphen T. What is it? I will give the image name as scratch, something like SCRATCH colon something like test, and say dot and say enter. You could see that you have built an image. If I try to do a Docker image ls, you could see that, guys. You could see that. Oh man, how it is actually 518 MB? It would be it is zero only. It should be zero only. But what happened now? They have added something. This also can be used. Actually, this is a very less actually. But actually, what happened, right? If you use the scratch, right? Scratch basically will be a 0 byte. It will show as a zero actually. But very strange that it is showing some size like 518 MB. Okay, I will try to find out, guys, why it is showing 518 MB. But usually it should show as a 0 byte actually. So it doesn't have the size should be always be zero size actually. Even you can use the scratch also, and many times we use the scratch also. Even like for example, Alpine. If you take Alpine Linux image, Alpine intern uses the scratch image only actually. On top of that, Alpine you'll add some more many commands, libraries, and all be adding to make it as a lightweight image. But Scratch is something which many other images uses the Scratch image actually, because Scratch is a 0 byte image. It doesn't have any kind of a content. But here I'm it's for me it's very strange actually, because last month when I used this Scratch, right, it was showing zero. Now I don't know why it is showing 518 MB. Strange man. I'll try to find out this answer for this why it is showing 518 MB. Yeah, but we can use it actually. Okay, guys, good. So now fine. So it means that I can use any of this image actually for doing it actually, right? Now, once we did all these things, guys, so let me go back to our own old one, like Dockerfile one. So here we have used this Eclipse image and also some kind of a label I've used. So I can use any one of this label. Let me remove all these labels. This one I'll remove so that we will remove this. We will try to avoid using this. Avoid using. I mean, as of now, we will avoid using this. But this is how you have to use it in an organization. But as of now, we'll try to remove this. Let this label be as it is, because I'll be using this older way of representing the labels actually. Right now, what I will do that basically, guys, the next instruction after the from and after the label, what is the next instruction? I will use it. I will use some instruction known as a run instruction. A run instruction, basically, this instruction executes any kind of a command during the image build. Actually, it means that this run instruction executes the command during image building. During image building. Okay. Now, here, for example, let us do one thing, guys. For you remember that whenever I try to have a Ubuntu image, whenever I try to have a Ubuntu image, I'm just writing here. When you are having a Ubuntu image or when you are having a Ubuntu OS, so like Ubuntu 24.04, I'm just taking a Ubuntu OS. So basically, what happened that you run some command, right? Sudo apt update, like this. You run the command, and also you will try to use sudo apt install some package. Like for example, if I want to install wget, I'll use wget. I will use something like a unzip, and I'll use something like a tree package. So you know that we try to execute all these commands. So why we run this command, guys? Because that you are installing certain packages actually. That's what. Now, similarly, when you want to install certain package, when you're building a Docker file, in that case, how you can able to execute all these commands, what are all the you are using, right, while you image building? In that case, you use this run instruction actually. Run instruction is like executing the commands in a command line. So similarly, when you are using certain base image, on that base image, you want to install certain packages, or you want to install some commands, or you want to do certain things, then you use this run instruction actually. So what I will do, guys, I will not touch this. Let this be as it is. I will not touch this. Let me do one thing. Let me create one more file under the experiment. Something like uh, I'll use something like Docker file 3 only. I will use it actually, right? So this is the folder, and inside this folder, let me create one more Docker file. So why I'm doing all these things, guys, you will see it in some time. You'll get to know about all these things. Why I'm just writing all these things, because I want to just show the differences between all these different Docker which you're building. You'll get all kind of information now, like okay, why I'm doing all these experiments. Okay, because we are building. we are building our image, right? From first we started with the base, and then we started with the label, and then we will go with the run instruction. Finally, we will be using something like add or copy, CMD. Like that, I will be keep building my image. So it means that I am just writing my Docker file from the base, from the scratch I'm writing, but I'll be slowly introducing one after another some instructions, so that I will get to know how to write a Docker file from in a very high level. That's all, right? Now, what I will do, guys, like I'll do one thing. I will try to use the from instruction, and I will use a Ubuntu image actually. Ubuntu, what is it? 24.04. So this image already exists, so I'm using this image. Fine, good. And then like I will use the label, same thing. I'll use something like a author is equal to something like Rajesh. Okay, anything can use it. And the label, what is it? I'm using something. Project is something like a classroom project. Okay. And here what happened after that, what I will do that, guys, I will use something as a run command. I'll just say run. And here I want to run sudo apt update. I'll just say apt update. Okay. So shall we run this with this three instructions? Guys, let's see whether how it works. So let me copy this whole thing. Consider the following Docker file. Okay. This is the file you're writing actually. So what I'll do, I'll go here and I will come out from the Docker file to, I'll just say mkdir docker file 3, mkdir docker file 3, docker file 3. I'll open a file by name docker file, go to the insert mode and copy, paste all these three lines. Am I clear, sir? Let me save this file. Now, when I try to do a Docker image ls, you could see that, guys, I use this experiment v1, v2. Now, which I'm building will be v3 actually. Am I clear, sir? I'll be doing a v3. Now, what I will do that, I will just say Docker image build -t. I'll just say experiment experiment v3 because the version 3 which I'm building space I'm using known as a dot. Enter. Can you see here, guys? Run apt update is executing. See now how it is running because you have used the run instruction. So run instruction was, as I said, right? Run instruction is execute the command during image building. When you're trying to do an image building, when you're trying to do a Docker image build -t, whatever the run instruction which was there as part of your Docker file, this is a run instruction. This will start executing during build time. Am I clear on this, sir? Now you could see that once it downloaded the image, base image, then it started running this run apt update command, right? And you could see that actually it has created this experiment v3. When I try to do a Docker image ls, you could see that you got this v3 version. Am I clear, sir? It got the v3 version, right? So now what you say that, okay, fine, now I got it. So it means that on top of this Ubuntu image, you are running this instruction apt update in this image itself. Yes, we are running this apt update inside this image itself. Like that is Ubuntu 24.04. Now you say that I want to install the OpenJDK. OpenJDK 17. Yes, you can run, you can use one more run instruction, run apt install OpenJDK -17 -JDK -y. Right? So you can use either this way, guys, but what they use in the standard, basically in the standard practice in the organization, whenever you want to use any kind of a run instruction, we will be executing this command, sudo apt update or apt update, yes. And one more instruction if you want to execute means you will try to run as part of the same run instruction. You will not use multiple run instruction. If you're using a multiple run instructions in your Docker file, your Docker file size will be unnecessary. It will be increased actually. So why it is unnecessary increase and all, we will discuss all those things in our later class. Don't worry. But as of now, what I'm saying that if I'm using multiple run instruction in the same Docker file like this, for example, if I'm trying to run like this also, if I'm trying to do an apt install, what is it, wget command, run app install, unzip package. You are trying to run so many run instructions, it will unnecessarily increase your Docker image size. So you don't have to do that. So what you have to do is, as part of the first run itself, you want to do all these operations. Then how to do it basically, guys? You have to use something like this. So remove all these things. Even remove this run instruction, the first, this one, the run instruction. And then like what happened, you have to just say and you have to say slash. So what it says that you have to use and means basically what you are doing is you are saying that okay, here when you are calling a run command, run instruction, you are executing the app update, and that means still there are other commands are there, or other things are there to be installed actually. So you use and then slash means it is a continuation. It means that run instruction, what happened, it will try to fetch from the next line which what you have to install it, right? So if you're not using this slash, right, then it doesn't understand okay there's a continuation of the run command here also. You'll not get to know. You have to use always slash. Hence what happened, right, whenever you are installing multiple kind of a package, we use and say slash. Either you can do this way or either you can use this way also. Both are same like this. Either you can use this way also, right, like this way also. You can use this way, but what happens since, right, it looks little clumsy in the same line, right? So many you are writing. Hence, what happened? What they said, don't use this way. Instead of use this way. Enter, enter, and enter like this. But how do the run instruction know that okay, there's a condition in the next line? In that case, you have to add this slash like this. Slash here, and slash here. Like this, you have to add it. In that way, the run instruction will get to know, okay, the command is continuing even in the next line also. So this looks somewhat good, okay, because guys, this looks good because you are giving a multiple instruction for your run to install it actually. So what happened? First, this will get executed and it understand, okay, there is a continuation next line. So it will say slash means, oh, it will go to the next line. It will also try to run this instruction also. And again, oh, there is still more there. It will try to run this also. And finally, it will try to run this also. Like this, it will run it actually. Am I clear, sir? So I'm not installing all these things. I will just go with only installing only these two lines. That's all. Right? So first I'm running an apt update and then like I'm installing the OpenJDK 17 package also along with this Ubuntu only. Is it fine, sir? Do you have any confusion, guys?
No, Rajesh.
Okay. So this is what. So it means that now I added a run instruction. Earlier I just run sudo apt update. Oh, sorry, apt update. Now I'm installing certain package that is OpenJDK 17. Okay. Let me copy this whole thing and come here, and since I have a v3, now the next which I have to build is a v4, right? So I'll just try to open this Docker file. I'll try to remove all the things and just add the new one. Oh, sorry, let me copy this, add this, okay, and save this file. Now I'll try to run a Docker build -t or Docker image build -t experiment colon, what is it, v4 on v4 space dot and say enter. So now you could see that, guys, it is sudo apt update is running, right? But also what you could see that it is also running a sudo apt install OpenJDK 17. This is what the package it is installing actually. But if you watch it carefully, guys, it actually what happened, right? It is using something like a cached actually. So cached basically what happened, right? Already you had built the previous versions like experiment v3, experiment v2, experiment v3. What we did basically, guys, in experiment v3, we had run up to here. Up to here we have run. So it means that it is considering the image. Yes, it is also installing, or it is also running this command also, apt update. So what happened, already we have image which already the image experiment v3, it already had all those instruction. Now what it is doing basically, like when you are building the fourth image, it is not doing from the scratch, it is taking directly from the cache actually, all the instruction. Only which is it is trying to do is nothing but apt install OpenJDK. This is the only last instruction it is executing, that's all. Apart from this, all other things and all, it is directly taking from the cache itself actually. That's what you could see, that it is taking from the cache. So it means that it is not building from the scratch actually. It is already taking something from scratch, cache, and later what happened, right? What are the other remaining instruction, new instructions are there, right? That only will get executed. So you could see that only this is getting executed actually. Am I clear, sir? So if you don't want to use this cache, if you say that, okay, Rajesh, I don't want to use from the cache, it should always freshly build. Always it has to do a freshly build. Then there is something like hyphen fn no hyphen cache, something is there. That option is there. You have to use that option for building it, right? How do you get it? Let's say, let this completes, then we will see it actually. So for the first time, it has took time because you're installing some package, OpenJDK package, right? It will take some time, but eventually what happened, right? Next time when you're building, it will become very fast because it will try to take everything from the cache itself. So now you could see that, guys, it has built it. Now if I try to do a Docker image ls, you could see that we got the fourth image, the X1 V4, right? And you could see that the size has increased now because you have installing some OpenJDK package actually, which has consumes more and more disk space. Hence, you could see that the disk has gone very high, 1.3. Am I clear, sir? It has gone to a little high actually size. So now, as I said, right, this is okay. But if I try to do a Docker image, build hyphen f and help, if you see it, you could see that hyphen fn no cache is there. It do not use the cache while building the image. So if in that case, suppose assume that I am building the same image, okay, with the hyphen fn, hyphen t, hyphen fn no cache, no cache, hyphen fn no hyphen cache. If you do this one, uh, Docker build build x, huh? Oh, Docker build x option. Docker build image build hyphen fn no hyphen cache hyphen t ex print v5 I'm giving unknown
With
hyphen fn,
space image.
huh?
Space image.
Oh,
Image.
it should not take the cache, but why it is taking from cache? It should not take the cache actually. Open JDK 17 y colon. Did not complete successfully. Exit 0. Why? What happened? Strange. Oh, you don't have enough space, man. Oh my God. That's the reason actually. Oh, I have to remove all the things. Docker image list. Guys, I have to remove all the things. Docker image RMI, Docker image ls-q. Okay, and Docker image rm-f dollar of this command. I'm removing everything, but let me build up from the v5 onwards. Okay, right? v4 is there, v5 onwards I'm building it. So when I try to do Docker image ls, so now nothing is there. Now I try to run the same command, the last previous command, and I'm trying to build from the scratch. Why it is taking cache 1/2? It will not take from cache. It has to build from the scratch only. This is again a new thing which I'm seeing it. Okay, that's fine. Let's see. Let's proceed. Okay. Yeah, I think it's building from scratch, hence it is taking time, but okay. Okay, let it build, guys. So now, after doing this, actually, so we executed three things. We use three things. One is a from image, from instruction, sorry, and other is a label. We saw it, and then finally we use the run. After that, what we have basically. So basically, guys, we have many other instructions. Like for example, we have add, and also we will use something like copy also later. So what is add? Basically, add instruction. It can copy files from local as well as from web into the Docker image. So whenever you want to try to copy any kind of a file or any kind of a data or any kind of a zip or a tarball inside the image, then we use this add image actually. Add instruction we use it actually. Right? So similarly, even we have a copy also, guys. Copy also is one of the instruction. Copy instruction can copy the local files or folders into Docker image. Like, right? Now, what is the difference between add and copy if both are doing the same thing? So add, as I said, right, add will try to copy the file from the local as well as from the web also. Say, for example, in the website, in the web, somewhere in the website, you are having some kind of a tarball actually, or some kind of a zip file, or any kind of a file you are having, either tar or zip or whatever normal file you have, normal file. So from the web, actually, you can, if you want to download from the web, then use the add instruction. We use it actually. And one speciality of the add is that actually that add can try to copy a file from the local to the inside the Docker image. That is one thing. Add can also copy a file from which is there in the web into your Docker image. That can also be done. But one more important thing, what add will do that basically add while when it try to when it try to copy the tar or a zip from web to the Docker image, it will copy and it will extract also. Both the operation it does. It means that suppose you're having some kind of a tar file which is there inside from the web or else locally also. Suppose you're having some kind of a local tar file. While copying it, or you want to copy it, means when you're trying to call an add instruction, what it does that it will try to copy that tar file inside your image, as well as it will extract it also. Both the operation can be achieved with the help of a single instruction, which is called as add. But copy is something like where it will just plainly copy it. Suppose if you're having a zip file, you try to copy the zip file inside the Docker image, it will try to copy the same zip file. It will not extract it actually. Similarly, right, whereas an add, what happened, right, it will try to copy and then it also extracts. Both the operation which taking care, that's what add is more important compared to the copy actually. Copy means plainly copy like that. So this is what the difference they will ask in what is the difference between add and copy. You have to say that add does multiple options, multiple ways add is used. One is that you want to copy add means copy something from the web into inside your Docker file. You can call an add, but the copy cannot copy from the web actually. You cannot use copy instruction. Only add is used. Add, the second important, that add can also be used for copying the local file also. That is the second point. Same thing like a copy. Add one, what add does that, if there is a star for a zip file, while adding it, after adding into that specific path into the Docker image, it will also extract also. So that these 3 points you have to tell in a front of interviewer, the difference between add and copy. Am I clear, sir?
Yes, Rajesh.
Yes, I think most of you already know this, right? We know all these things, but anyhow, we will see it when we try to see the examples, right? We'll get to know about all these things actually. Right. Now, what you're saying that, okay, fine, Rajesh, now I want to download some kind of a jar file and I want to copy it. Say, for example, here, for example, while running it, I'm installing it actually. After that, what happened, right? I want to even copy it. For example, if you go to yesterday's class, in yesterday's class, was what I did, right? See, I tried to use an add command and then like you could see that I copied that Spring Pet Clinic which was there in my S3 bucket, right? So this is my the complete URL actually. So I copy it. So basically what I will do that I will try to call something like an add here, add space, give the complete path. This is a source actually, and the destination is slash and give this name. It means that you are trying to copy inside the slash only the Spring Pet Clinic, you're copying it. Am I clear, sir? So add insertion, you're trying to copy the file, which is the Spring Pet Clinic hyphen 3.3 hyphen 0 snapshot dot jar. This file you're copying inside your Docker in your Ubuntu image, and you're copying in the as a in the slash actually like that you're copying it. Right? Correct, sir? So shall we now write it the same thing? Yeah. Go back here. Let's see whether it is built or not. You could see that it has built, guys. So if I try to do a Docker image ls, you could see that actually that it has built and the size is 1.3 GB. Let's see whether I have a, see 93 GB is already used actually. Use is 6.3 GB. Only available is 490. I don't know why it has took so much. I should have increased my disk space, but that is fine. It means that I have to keep removing all old image. I have to keep removing it because all 6.3 GB is already used. I should have took some big like class storage. Next class what I'll do that I will create a server actually, a Docker server where I'll try to take something like 15 GB or 20 GB of the storage I will take, and then like I will have a more disk because in tomorrow's all our upcoming sessions we will be building so many images actually. So I need a disk space also, right? For that I need it actually. So now what I will do, guys, I will try to have the same instructions, all these instructions to run in the Docker file. So anyway, this will fail actually. We know that because already 1.0 GB is already been occupied actually, right? So then what I will do that I will try to remove this image actually. So Docker image ls, you could see that it is a v5 is there. When I try to build for the next time, it will be v6 actually. But let me remove that Docker image RMI and then say and then give the ID. So you're removing that image. When you try to do a Docker image ls, now you could see that there's no images exist. Now I don't think I'll open the Docker file. And here what I'll do that I will try to remove all this line contents and I'll go to insert mode, try to copy this whole instruction and paste it like this. Am I clear, sir? Now I'm calling an add instruction actually. So what it will do that, it'll try to download this file from this path and it'll try to keep inside your Ubuntu image under the slash actually. Save this file, and when I try to build the image, I'll just say docker build, docker image, build -t, and then give something like experiment colon. I'll give v6 and then say dot and say enter. Again, this will take time, guys, because every time we are building. But you can ask me, Rajesh, is this a proper way of the way we are doing? This is not the proper way, guys. This is not the correct way, the way we are writing a Docker file, and it's not a correct way, the way we are building it. We can improvise it. For timing today, we are just trying to follow some kind of a rudimentary way of running our application by using this Ubuntu. But tomorrow we will not be using this Ubuntu image. We have to use some lightweight image. You have to use it. So that we will be using it so that we can run our application even with the help of a light image also. So Ubuntu is a very large image, right? It'll itself will consume around more than 500 or 600 MB, right? So we don't want to have any image which is having a larger size as a base image. That's a best practice what you have to follow. We need to have a lightweight image actually. So we have to select either lightweight image. So instead of this, what we do, we will use, you know very well that we will be using either OpenJDK. We have to use either OpenJDK -17. That is the image we'll be using. Okay. Or either we'll use this, or either we will use something like an Alpine image. Okay. Or else you can even use an Alpine-Slim image. So these are some of the images which we will be using in our upcoming session. We don't want to use this Ubuntu image. Ubuntu is a large image actually. Ubuntu 24.04, whatever the image which you are using, right? This is not the correct image, or this is the large image which is not really no feasible to use in our requirement. So we will always use some kind of a slim image. So you have to use any one of this image. You have to use it. So go back here. So it's almost done actually. So it has completed. It is completing it. Okay, let it build. And now we will try to run this image actually. And run this, we'll try to create a container out of this image and we'll see whether our application is running or not actually. Okay, so we have built the image, guys. So when I try to do a Docker image ls, you could see that it is built and the image size is 1.4 MB. That's a 1.4 MB. What is the disk is available as of now? It's just 262 MB is the disk space which is available. So can I run a container, Rajesh, with this limited disk space? Yes, we can run this container. Okay, with this limited also we can run this container. So let's see whether to run this container. So what we'll do that, guys, we will try to use I'll try to run this because now you could see that actually that my application is there, right? And also I copied. Let's see whether it runs or not first. So what I'll do, I'll just say Docker container run, what is it? Run hyphen name. It is Spring Pet Clinic. I'll just say Spring Pet Clinic :1 or Spring Pet Clinic 1 space. What is the image name which you want to give? Like experiment 1. I'm not detaching, I'm not doing anything. Let's see whether how it runs in a foreground. So I'll give this image name experiment. What is it? experiment :v6, right? Yeah. Let's see, guys, whether it runs or not. Okay. I think I have to give a name, proper name. I'll just say SPC and say enter. Yeah. So it has run. So did it run this guy? Did it run or not? Let's check Docker PS. Okay. Oh, it means our content is not running. Okay. When I try to do a Docker PS-A, so you could see that your container experiment v6, right? It has run, but it has exited out. Safely it has exited out actually. It means that this was not at all run actually. This was not run at all. Why it was not run? Why it didn't run actually? So guys, any reason of why it is not running? I copied it. Okay, this Spring Pet Clinic I copied to the slash, but so it's fine. But do you provided any kind of an instruction to run this? You know that when you want to run
No,
this application, you have to use Java-jar and Spring Pet Clinic, right? Have you given any kind of a
no.
CMD or in the run instructions here? No, right? Then in that case, it is not running. Okay. So it means that when you are running an application, you have to always pass some kind of a Java-jar, Java space -jar space, specify your jar file, right? What is our Spring Pet Clinic is that? Then it will run. Okay. But if you see in our previous example in last session, I use something like a website and I have a Docker file. Here you could see that I'm having a base image as an Nginx. And what I did, the whole HTML, I copied into the slash user share Nginx and I also use expose 80. When I try to build this Docker image and it was trying to run right, it was actually running actually. It was actually running. You remember it was actually running. I was able to access that application, right? So here what happened, right? Here, if you ask me, Rajesh, where is the CMD here? What where is a command and where you are actually running your application? You're not running it. Okay, if you're not running, then how our application was running at the time? See, for example, assume that actually, let me know then because guys, this again, this image is taking a lot of space actually. I think I have to remove Docker image rm-i and then specify the image ID. I have to remove guys because I don't have a choice now at this point of time. Yeah, it was running. So it's been used actually. I can use a rm-f, right? Forcibly, I can remove it. Yeah, you can remove it. Now, when I try to do a Docker image ls, it is not there. Now, if you go back here and if you go back to your this Docker file, right, which has this image. So, Rajesh, shall I build it? Docker build. Yes, image, Docker image build -t. If you remember, Docker build -t. Okay. What is the image name you give? Something like my web actually. My web colon 1.0 something and I'll give dot. See, it builds this image. So what I'm doing guys now, I'm trying to build this image actually. Nginx and this one and then like basically and now what happened, it has built image. When I try to do a Docker image ls, you could see that actually this image has been built. Now I want to run the container, right? I'll just say Docker container. Okay, I'll just say Docker container run hyphen d and then I will just say hyphen name. What is it actually? Uh, my web actually. Then I will give something like this is the image name I'll give. Right? What is the image name? Because I'm not able to see that. Yeah, my web, right? So Docker container run hyphen d. Okay, hyphen name. What happened, right? My web, right? And then I have to even use a hyphen p because I have to use a port mapping, right? And then I will give this image name, my web colon 1.0. You could see that guys, your Docker image is running. When I try to do a Docker image ls, you could see that actually your
It's container, Rajesh, sir.
sorry, Docker containers. Docker containers, you could see that it is running actually. Right, and you could see that your application exposed to 32771, and you'll be able to even access your application also. So you can copy your public IP, go over here, and give the port number. What is the port number, guys? 3232771. See, 32771. So you're able to access this application. Now, how all of this sudden it's happened? Because when you see this Docker file, you're not using any kind of a CMD or run instruction. You're directly using it. But whereas in the previous case, when you are trying to use a Ubuntu, it just exited out, right? When you try to use this example, that this one, you saw that actually you didn't use any kind of a CMD, right? So it means that when you try to run this image, it failed. It didn't run this application at all, right? So what is the reason, guys? So the reason is simple, guys. The reason is that when you try to use here, when you try to do the Nginx, right? Nginx base image, okay, Nginx base image. Okay. So we'll write a note on that. What is the note means? When we create a container searches for the startup command. Startup command. Like for example, it always checks for the CMD or I can say entry point. CMD or entry point, right? Right? Here in this case, in case of our first example, in this case actually, because I'm using a from Nginx instruction, Nginx. So I'm using from Nginx. Nginx base image has the default CMD or entry point instruction through which by default the Nginx image will be running, right? Whereas in this example of Docker 3, where you are having a Ubuntu image, Ubuntu 24.04 image, okay. So Ubuntu 24 image doesn't have any default CMD or entry point instruction. So here what happened, guys, in your case, so by default, this image doesn't have any kind of an entry point or CMD. It is nothing like an instruction to run this image always, right? And also in your Docker file also, you have not used any kind of a CMD. Suppose that what the Docker will do that when you are running this image, right? What happened? First, it will try to check is there any kind of an instruction which is already there inside the image. If it is not there, then it will try to search. Okay, if it is not there, it will try to search here whether a user has called any kind of a CMD or entry point. He has not called it, then what happened, right? It will create the container, it searches for the startup command, okay, either inside the image or outside, or nowhere it found, and then it simply exited out. Whereas in this case, what happened right here, you need not to write any kind of an experiment, you need not to call any kind of an explicit CMD command or entry point, it's not required because Nginx itself has a startup command actually. Hence what happened, right? You could see that your Nginx is running actually. Your container is running actually. That's what if you just say Docker container ls, you could see that actually that it is still running. So it means that Rajesh, now my question comes that Docker container ls. Now you might ask, Rajesh, how long my content will be running? How long my content will be running? So my content will be running till the CMD or entry point will be running. As soon as the CMD point will get exited out, or either entry point will get exited out, it means that even my content will also get exited out. So always that is a main question which they'll ask in interview. How long you when you say that, how long you say that your application will be running, whether your application will run for 1 day or 1 hour or for 1 year or 2 years, how long your application will be running inside a container? Can you tell me? You have to say, sir, you have to just say that actually till the CMD is running or till the entry point is running inside my image, right? Till that point, my container will be running. As soon as the entry point fails or CMD fails, even my container also will fail. That's all you have to tell. So whether you will be explicitly calling your CMD outside the image or else you will be using the entry point or CMD which the image itself will provide. It depends upon your requirement, you will say. Right? It will say that even though you said, okay, my base image also provides the CMD, but explicitly even I have to define outside my image. It means that while writing a Docker file here also I can call the CMD. Especially I can call it so that my Docker file will be highly robust. It means that at any cost my Docker file or that image which is running it will not fail because I'm explicitly calling the entry point CMD. Right? I'm not using the base images CMD or entry point. Yeah, that is also fine. It means that explicitly you have to call it. In this case, what happened, guys? There you are not calling anything CMD here. Hence, what happened? It just starts the container, but since it didn't find any kind of a startup command, immediately it exited out. Actually, immediately it exited out. Am I clear, sir? Did you understood it? Right. So when we create a container searches for the startup command, like either CMD or entry point, whichever. So entry point, what is it? We'll see in the next class. If not found, it searches in the base image startup actually. Am I clear, sir? Hence what happened, right? In our case, in this case, in this Docker file, here you have to explicitly call the CMD, right? So that's what we need to understand about the CMD. CMD or entry point. Entry point we'll see it later. So CMD is used for the start up the application. Start up the application. Am I clear, sir? Right? Now, for example, assume that if you go for the Linux, right? Basically, guys, you have something like a sleep command. If you can see that if I say just a sleep of 3 seconds, you could see that it will sleep for 3 seconds and then it will try to come out. So Rajesh, can I use the sleep? Yeah, you can use sleep also. Sleep will also. So if I say sleep of 15 seconds, it will go for sleep. Like for example, here, in this case, Rajesh, what you are seeing here, can you use a sleep of something 15 seconds? Yeah, man, you can use sleep also, or 15 seconds also. So shall we build an image out of it? Yeah, you can do that way also. For example, if I think I have to always remove the image actually, Docker image ls. I'll just say Docker container stop or Docker rm-f. I'll give this image name. What is it? My web actually. I'm removing it. Docker image rm-f and give this image name or image ID. You're removing it. When I try to do a Docker image ls, right, nothing is there. So now what I'm trying to do is that I will try to go with the experiment folder. I'm just showing you Docker file 3 and open the Docker file. What I will do, guys, I'll just try to add one line. That's all. Let's see how it works actually. Sleep of 20 second. 20 second, I'll just say. And let's see whether your image will be running or not. Let's see. I think I have to build it again. Okay, Docker build -t. Where it went, man? Docker build. Docker build -t. I'll just say let it be v6 only. It doesn't matter for us, right? Mm-hmm. Why it is unknown instruction? What is the wrong thing that it meant? Did I miss it? Sorry, man. Shit. I should have used CMD, no? CMD sleep. Okay. This takes time actually. So next time I'll have a larger disk space, guys. I'll take some 30 GB, I'll take this space. So that we need not to always clean up all these images and that's not really required. It is required, but like we will not be able, will not, it's not really required to do every time. But again, my question is that if I try to do a CMD of sleep of 15 or 20, whatever, Yeah, your building image when you try to run it, yeah, your container will be running actually. How long it will be running? Till the sleep expires. Once the sleep is expired, automatically what happen, your container will get killed actually, exited. But that is not the thing, right? Or do I need to always make it sleep for always? No, right? That's not our purpose, right? Our purpose is to run this Spring Pet Clinic application, right? It's not like to keep in a sleep, right?
Yes, sir.
That is not our requirement. Our requirement is to just run it. I have to use a proper Java command. I have to run it to run the application, right? Just I'm showing you for a purpose. Suppose I want to see whether the content is running or not. I'm just introducing sleep command. That's all. Just to show you in the class. Guys, sorry it took some lot of time today, but anyhow, I thought I will cover more today, but anyhow, that's fine. I think again I have to build it because next I have to call the CMD for running your Java application, right? Oh man, this is taking so much time. JSON argument, warning, Docker, debug. Okay, I think failed to build. My God, why it is actually no space left on device? It is not build only, guys. It's a gone case. It's not build only. So what we'll do, guys, we will stop it here because I will try to. I'll try to have one more server, a new server. I'll launch it actually, where I will have more, like this space. Instead of taking 8 GB default, right? I will take as a 30 GB of this space and I'll show it. So what is my main intention is to show you that actually now this time what happened, right? I will be using something like this actually. So through this way, what happened, right? I will be building an image. I mean, I'll be running it. I'll be passing these three instructions to the CMD actually. Right? Java hyphen jar and specify it. Now what happened? It will run your application. So whatever Spring Pet Clinic is there, right? It will run it. But is this the correct way of building, Rajesh, for running the Spring Pet Clinic? As I said, no. Because you're using some base image which is a large image. And the best practice not to use and the best practice is to always use some kind of a light image, not such kind of a big image. So this we don't use it. We will use some other image in our upcoming sessions. So, right now we are not using. I mean, just for our understanding, we are just running this. We'll build out and we'll run it, but usually we don't do it actually. We don't use this Ubuntu image. So guys, what I will do that I will stop the session now. What we are going to do, we will meet up tomorrow, and then I will continue from here itself. Okay, we'll building this image. We'll build this image, and just remember that we will be building like experiment V6 actually, version 6, where we will be building an image and we will be running this image actually, right? Just to show you, and later we will try to, we'll try to use some kind of a other image and to make sure that with the help of other image also you can able to run the same Spring Pet Clinic. After building, you will see that actually what happened at whatever your 1.5 GB which was used earlier, right? Now you'll see that it will only use some 200 MB or some 300 MB. Within 200, 300 MB, you'll be able to build an image and then you will be able to run the same application with just a smaller image size actually. So our main intention is that our image size also should be very, very small, right? We can't have a very big image size actually. Okay. So with that, I will stop it, guys. Tomorrow we'll meet at around evening, around 7 p.m. IST. We'll meet tomorrow, Monday, right? We'll meet tomorrow. Tomorrow morning, let's have our AWS class tomorrow. Okay, we'll continue with the networking. In the rest, another remaining 2, 3 sessions are there, guys. I'll let me try to complete in next 2, 3 days all the things, all the small topics. Okay, so we'll be completing our AWS networking part. So with that, guys, thank you all. We'll meet tomorrow then. Okay. If hopefully, if I'm free at the evening time, I might call at 8 or 9 o'clock. I'll call. Let's see how many people will join. Okay. If not, then we'll give a break and we'll take tomorrow only. Okay. Thank you
Okay,
then. Thank
Rajesh.
you all.
Okay,
Yeah.
Rajesh.
Bye-bye.
Thanks.
Yeah. So we'll continue from here only, guys. Sure.